Okay, so I did the video that looks at investigating solving quadratic equations by factoring. Okay, so you can watch that video. You can also kind of get the idea just from this video, which I'll make a little shorter. Okay, and it's just kind of reminding you, first of all, how to factor equations. Okay, and there's just a few ways basically that you're going to factor a trinomial um, if you see it in this form. Okay, and one of the ways well, I guess if you just see something like an x squared minus another square, okay, that's one thing that you might look for. That's just a difference of squares, so hopefully you'll remember that it is the square root of the first term minus the square root of the second term, and then square root of the first term plus the square root of the second term. Okay, and you might also see a square trinomial, which we used when we factored the difference of squares. Or sorry, when we factor, which we used when we completed the square. So 4x squared plus 12x plus 9. Okay, we know that this is a trinomial square because this is a perfect square, 4x squared. This is a perfect square, and this number is 2 times the square root of the first term, which is 2x, times the square root of the last term, because 2 times 2 is 4 times 3 is 12. Okay, and x. And remember, this can be positive, an addition or a subtraction there. Okay, it's still a perfect trinomial square. And so when you factor those, it's just going to be the square root of that first term. Okay, you match this sign, so it's plus, and you want to have a plus, plus 3, the square root of the last term, and squared. Okay, so just a little practice. The difference of squares, that's one special one. Trinomial square, that's another one. And then if you just have, so that's this here, right? And you know, I think it's funny that they don't have, those are the first two that you should look for because they follow such a simple pattern, okay? And then you might get to something like this. So 4x squared minus 2x minus 12, okay? And so the first thing you always want to do is look for a common factor. Okay, so for this one, you'd probably take that factor out. Okay, and then the next thing you need to do for this one is what you want to do is you want to just split that middle term into two other terms, okay? And I hope that you remember how to do this because I'm not going to go into it in a lot of detail. But what you want to do is take the 2 minus the negative 6. Hey, that's negative 12. And so you're looking for two numbers that are going to multiply to give you negative 12, and they're going to add to give you whatever that coefficient of the x term is. Okay, so they're going to add to give you negative 1. So a pretty simple way to do this is just to sort of start with negative 12 and look at all the ways you could have got the pairs of factors that you could multiply together to give you negative 12. So negative 1 and 12, they add to give you 11, or in this adds to give you negative 11, so you know that's not what you're looking for. Negative 2 and 6, and 2 and negative 6. Okay, that's negative 4. That's 4. So no good. Negative 3 and 4, they add together to give you 1. We're looking for negative 1, so we keep going in 3 and negative 4. So that's what we're looking for, is 3 and negative 4. Okay, those are the two numbers that will multiply to give you negative 12 and add to give you negative 1. Okay, and so then what you do there is you're going to replace that negative x term with these two. Okay, so we're going to put 2x squared minus 4x plus 3x minus 6. And it really doesn't matter what order you put them in. It'll work out anyway. Okay, so I'll just put a square bracket because I want to keep that 2 on the outside. And maybe you remember with this step, you factor it by grouping. So you take the greatest common factor out of the first two terms. That's going to be 2x. And so you're left with an x minus 2. All right, and when you take the greatest common factor out of the second two terms, you're going to get 3, and that leaves you with x minus 2. Okay? All right, so when you bring that back, you're going to take the x minus 2 out of there. And so when you take it out of here and out of here, you are left with 2x plus 3. Okay, so that's the factored form. You can get rid of those square brackets. You don't need them. Okay, but yeah, if you're looking for the factored form of the equation, you want to keep that 2. Okay, now the reason why we do this is when we're factoring is when you actually group, okay, you're going to be able to tell what your intercepts of your equation are from these factors, okay? Because y is going to be equal to 0 when either this factor is 0 or this factor is 0, okay? So when x minus 2 is equal to 0, or solving for x equals 2, that's going to be one of your intercepts, okay? So you're going to have an intercept at 2, an x-intercept. You're also going to have an intercept when this factor equals 0. Okay, so 2x equals negative 3, or x equals negative 3 over 2. Okay, so these are the two places that your quadratic function is going to cross the x-axis at 2 and negative 3 halves. Okay, so you don't have to graph it to see where the intercepts are. Okay, this function will cross the x-axis at 9 and negative 9. Okay, and this one will cross it, or actually it's just going to touch it, right? It doesn't cross it because it doesn't have two different intercepts. It only has one, so it must just be touching it. But it's going to do that when, I'll just finish this, when x equals negative 3 halves. Okay? All right, so that's why we do this in factored form. Okay, so we're just going to look at factoring and how that relates to our graphs. Okay, that's what happens in this section.